Okay, so can you guys see the desktop?
Yes.
Perfect. Let me go to connect. Oh, presentation. Okay. So let me give a quick introduction to the IIESoc and welcome to our first webinar. And thanks, Nalini, for taking over the technical topic. I will try to cover this fast so that we can move to the meat of the technical topic for which we are here. So who are we? We are IIESoc, which is India Internet Engineering Society. We are a non-profit entity that is working towards bringing industry, academia, service providers, and various government entities to work towards adoption of ITF standards in India and also increasing the awareness and participation of India in the ITF process. So as some of us have been going to ITF for a while, but we see that the Indian participation has been on the lower side. So this is our aim, to bring the right set of people together, increase awareness, the people who should be participating, get them there, and some people who are not aware of the standard making but have been involved in writing the code or doing the testing but not on the standard making process. So get them aware and bring ITF to them, and also the other way around. So this is our mission statement, some of which is kind of covered in our previous introduction already. We want to increase the adoption of internet standards in India, participation of Indians in ITF standard activities, capacity building programs such as this webinar, also work in the policy area with the government whenever they need any technical inputs from the right set of technical people working in that domain. Become a forum where we can discuss technical issues which are specific to Indian context. And we know that we have specific internet and networking problems which are unique to India. So we wanted to become the right set of forum to discuss them and then take it to ITF, mentor people wherever when they come to the ITF for the first time, and slowly rise in the ITF leadership as well. And our aim is to get ITF to India in future. India has been doing other, like there has been ICANN and other international meetings in India. So ITF seems to be the next a big internet meeting that we should definitely hope to have in India. So just a quick introduction to our structure. So we have a governing council, an advisory council, and focused volunteer groups that work on specific topics like webinar and other annual meetings, etc. I will provide you details a little later. So this is our governing council. There are a bunch of us from various different fields, some from vendor backgrounds, some from service, some have started their own company or consulting. So a nice group of people who have been involved in ITF activities for some time. So we are the governing people with Vinayak, who's present here. He's our president. I'm the secretary. And then there we have a bunch of other people from Bangalore, from Kolkata, from Delhi, etc. So it's a India membership. Then we currently have advisory council in which Nalini, who is also taking over our technical webinar today. So she has doing an amazing job in ITF mentoring program. So she brings in a lot of new people to ITF and get them involved in the ITF with the right mindset, introduce them to the right set of people so that they have a good experience at ITF. And she, while doing that, she's also CEO and founder of our own company called Insight Products, as well as multiple other initiatives. You can see the link in the bio, and it's a like amazing bio. And then Suresh has also been helping us. He's the Internet Area Director at ITF as a part of ISG, as well as a CTO at Kaloom. So he has been instrumental in helping us set up this society and helping us in running all these India-specific activities that we are planning. So thanks to Nalini and Suresh for that. So some of the events that we have planned, the main event that we have planned is the pre-ITF event. ITF 100 is in November in Singapore. So a week before that, we are planning an event in Bangalore. I will talk about that a little bit more details. I have separate set of slides for that. And I would like to introduce you to that event so that you guys be aware of that and think of how we can participate and make that event successful. Apart from that, we plan to do some hackathons related to ITF standards activity, webinar, which will start pretty soon, boot camps, which are focusing on increasing awareness to people, maybe at academic institution, etc. Some of the things we have done in the past, we have had social dinners at every ITF meeting so that Indians get to know each other at a social setting and try to help each other out and know, because ITF is a vast domain. And sometimes we stick to our specific areas. So this becomes a good way to socialize among Indians and Indian diaspora. We have also helped us in various other workshops, such as IoT workshop in ISC. We do one meetup called RFCs We Love, which just happened last week, where we talked about WebSockets, so which was very interesting. And we have been mentoring the new fellows, which comes to ITF, as a part of various fellowship program. So webinar, we are starting, and connections, which is our pre-ITF event. I will talk about it a little bit more in the next set of slides. Apart from that, we have also been working with other organizations like local ISOC chapters, RFCs We Love, and any other policy body that we would is working on internet standards and internet governance. So if you guys are already not on the mailing list, this is our ITF Community India mailing list. It's an ITF mailing list where we talk about all the India-specific events, and it's a good way to reach out to people when you need help, etc. We also have our website, which is IIESoc.in. We have all the other links that you guys can find out information about the events and other things. And we saw during the registration that people have found out about, for example, this webinar via different mechanisms, so which is good. That that some people are on mailing lists, some people found it on Twitter, some on WhatsApp. So there's a good way to disseminate information. So thanks for that. I will now talk a little bit about connections. Let me just make sure that the slides are still visible when I change. Can somebody confirm that?
We're not seeing new slides yet.
Okay, so let me just check. I was worried about that. Let me do this again. Because I'm not sharing the whole desktop, I'm just sharing an application.
Sure.
So let me share the whole desktop this time. For some reason, the whole, oh, is it visible?
Not yet.
No, not yet. No. Something is wrong that it's not letting me share the whole desktop. So if I need to share the application only. Okay. So let me open the application first and then connections. Let's share.
Okay, now we see it.
Perfect. Let me talk about our event. So this event, we are calling it Connections, both because it's a ITF event, internet networks, of course, and also because of the human touch, and we need to get connected with each other. So this is the name of our event, and it's a pre-ITF India forum. This is not an official ITF activity, but before ITF, we wanted to have a local event in India. This event will happen in Bangalore. So the purpose of the event, we wanted to get the right set of people across India who have been working on internet networks, operations, and designs to understand how the ITF standards impact their day-to-day job, and how they can start getting involved in the IETF standard activities. So we want to let this be a way for people to get introduced to IETF, because it's not very easy for everyone to travel to IETF every meeting. But so we wanted to give an opportunity for people to know what IETF is, how IETF works, what kind of technical work goes on in IETF, invite some key people from the IETF, as well as show some local Indians who have been working on standard making and what work they have been doing. So have a forum which deals with that. So both from the technical side as well as from hackathon and coding side. So the format of the event is it's a 2-day event. We will have a main event which will have various technical talks, panel discussions, etc. We will focus on 4 key areas, which is IoT, security, SDN, and apps area. We have experts from IETF which have vast experience, and they are especially coming to attend this event. So we hope that the participation from India is also very good, and people use this opportunity to learn and socialize with the IETF leaders. Hackathon, we also wanted to make sure that people who have, because we know that in India, many people have worked on standards and implemented them, tested them, and use their coding skills to show how the IETF standards are implemented and find issues with standards. So in the same set of technology area, we wanted to showcase the coding aspects, and even in IETF, the running code is the key mission. So we wanted to highlight that, and it suits our India and Bangalore ecosystem as well. So this hackathon would be a little different from the hackathon that we usually see, where a top-down approach, where the problem statement is given and people come and hack that problem. Here we wanted to let it be more organic, and since we have various different technical areas, we wanted to people to come in and bring their own problems that they are already working on, and socialize that problem and figure it out how it impacts the IETF standards as well. So this is much more open to people, and it's more bottoms up. So people who at universities, at their vendors, if they are working on some open source that they would like to highlight what they have been working on, this could be a very good opportunity to join and socialize this with other people who do the standards work as well. So this is the overall format that we'll start early, and we'll try to finish early. We will have keynotes, 2 keynotes, and we'll have 4 tracks. 2 of the tracks will go on in parallel. So this will be for our day 1. And the next day, which is hackathon, again, we'll start early and we'll hack the whole day. We'll have a introduction and finally hackathon results, where people will present what kind of work they have done on the day. So the tracks, we talked about it: IoT, SDN, applications, and security. I think all of us knows these things, and IETF has been involved in these activities. And even from the set of people who go to IETF or who are interested in IETF activities, I think this set of 4 tracks cover all of us pretty nicely. And also from academia, vendors, and government concerns, all of this is well covered in these technology tracks. So some of the confirmed speakers, we have Fred Baker, who is the past IETF chair, and he is a legend, and legend is a completely right word to use for him. And he's still actively involved in IETF, and he's graciously agreed to do the keynote for the event. So we are looking forward to that. Then we have experts also from IoT, like Professor Carsten Baumann, who is the working group chair, who is the Things to Things research group chair. He's the IoT directorate, and various other activities. Like people, he know him as an IoT expert worldwide. We have Paul Wouters, who is a security expert. He has been involved in open source activities for a long time related to security, and as well as he's the Trans Working Group Chair, Security Directorate, etc. And we also have the Tees working group chair and the NetConf working group chair, Mahesh and Vishnu, from who are also actively working on SDN, traffic engineering, and Yang and network management aspects. So it fits it into the SDN track. So these are the invited international speakers. Apart from that, of course, from India, we have a lot more speakers who are putting in their innovative ideas that they are working on. Some open source people, some from academia, some from vendors. So we have a very nice set of speakers for the event. And so please use this opportunity to come and attend. I covered a little bit more about Hackathon. I think the details are here. It's there on the website as well. So if you are interested in participating in Hackathon, please go through it. And if you have any questions, please get in touch with us. Also, please help us out. We would need more volunteers to help in doing this event. We are doing it for the first time, and we want to have a successful event with a very good impression of India, and both technically as well as in all other aspects. So please help us in publicizing the event in your organization. If you can spare some time, this is in November, so just a few months. So please volunteer for the event. If your organization would be interested in sponsorship, we have a link. It's there on the website as well. Please talk to your company or link us to your company, and we can take the conversation forward with them. So this is all about connections. If you have any questions, please go at us. And Nalini, Vinayak, and I can answer. Hello?
Yes.
Yeah.
Thank you so much, Drew. Mm-hmm.
Does anyone have any question? Vinayak, you said you can't hear. Is the problem solved for you? Okay, he can hear now. So I think if there are no questions, let's move to the technical topic. And I'll stop sharing. Off to you, Nalini.
Great. Okay, great. Let me start screen sharing. Then I'll bring up. Okay. Do you hear do you see my screen?
Not yet.
Yes, I can see it.
Yeah.
Okay. So I'm going to talk about TLS 1.3 and enterprise network management. This is one of the biggest issues at the IETF currently. What the problem really is, it's actually a one-line change that may be responsible for a multi-billion-dollar problem for the enterprise world. And what is that one line? It's out of the TLS 1.3 draft, and it came about very, very early. And what they did is to remove support for static RSA and DiffieHellman key exchange. The key word here is static. And so let me talk about what that whole thing means to enterprises and why it's such a large problem. I will also give you an introduction and the formulas for RSA and DiffieHellman, because one of the things that I've found is that if you really understand how these work, then you can function much better at the IETF. So what's the problem? Well, today, what has to happen at a bank, stock trading, anywhere really, any institution, you have to check for things like malware, viruses, whether your information is being leaked, and so forth. And of course, you have to balance the load between multiple, even ISPs, multiple links, and so on. And how do we do that? Well, we do that by diagnostics at multiple points. You may have products installed at endpoints, or you may be doing it in the middle. That is, you may be doing it on the network. You may have a link or a path that's goes through many middle boxes. And so you can't just monitor everything at the end point. You have to monitor in between things. And so there may be products or devices which sit in the middle, IDSs, IPSs, not firewalls, many things to detect whether some of this is going on. Now, the problem is, because RSA key exchange is going away, you will not be able to do this kind of monitoring that we do at just about every enterprise today. You will not be able to do it in the middle of the network. You will only be able to do it at endpoints. And why not? Well, how we detect many of these problems is that we have to look inside the payload of the packet. If the packet is encrypted, you can't see inside the payload. So you have to do what's called decryption. And today, how is that decryption done? Well, we take the RSA private key to do the decryption. And with TLS 1.3, the approved method for doing decryption is only at endpoints, never in the middle of the network. So today, at large enterprises, what we have inside the data center and going out all the way to the remote site is things like multiple servers, load balancers, routers, proxies, optimizers, and so on. Some of you may even work on such devices. And all these kinds of devices are not meant to do large packet captures. In fact, we tried to do one large packet capture on a load balancer a while back on a large network, and within 2 minutes brought the load balancer to its knees. It's not intended to do that. So what many people have done is they have what's called out-of-band packet capture. Many devices which do out-of-band passive data capture, and then you go back later and then you look at it. That way the network itself is not impacted. For example, here's one such, a product called Gigamon. You guys may be familiar with that. There's many competitors to Gigamon. And notice, this is right out of their SSL decryption screen. What they are using is the RSA public key to decrypt the traffic, because that is what is needed for things like diagnostics and detecting malware, et cetera. And I'll show you an example of exactly what might be and how you might do that. For example, let's just take one problem. Let's just take diagnostics. So let's say that you send this screen, the Google screen with the search box, and you go through, say, 10, 15, 20 middle boxes, and you get to the end. But at the end, you only have the top part. You only have the Google top part. Where's my search bar? Where's the search screen? That I have no way to enter any input. So what the network diagnostician has to do is he or she has to find where in the network that particular part was dropped, or is there something that was changed, or who knows what. Where's the problem? So often what you end up doing is you go from one box to the other. You say, okay, did I get to box number 1? It's fine. Wonderful. Box number 2, and so on. And that's just what you have to do. And oftentimes what you do is you read packet traces. you can see how, if you can't see inside the payload, you'd never know what was being sent or what was not being sent. Similarly, if you're testing for things like malware or some evil type of activity, you often have the fingerprint of a DNS name or a site, which is random letters and numbers, which was obtained maybe a few minutes ago. And so that's a fingerprint of a very suspicious kind of activity. Again, if you can't see inside the payload, then you don't know what's going on. And so a lot of these devices that are checking for things like malware, for doing diagnostics and so forth, this is the problem. What I'll tell you is when I first told about this problem to one of the enterprises that has been key in working on this initiative, they said, you know, my whole group might as well just pack up and go home now. Internet banking is going to be down for weeks and we won't know how. So how does this whole thing impact enterprises? And this is a list that's been created by a number of the enterprises that we work with. Following this whole issue, a lot of people in the enterprise community are waking up, and we have in fact started a group called Enterprise Data Center Operators, which we are spinning off into its own group. But what they said is, if you're doing any of this, internet banking, insurance, stock trading, or really anything internet facing or doing an internet encrypted application using TLS, the time that you're going to need to diagnose problems, it may be huge, because you're not going to be able to follow the path. You're not going to be able to decrypt packets out of band. You're not going to see where the problem was. And there are people who have said, why don't you just put in SSL proxies and do everything in line? It's impossible. Not only is it cost prohibitive, costing many, many, many millions of dollars, but the problem is that you have many paths, 10, 15, 20 hops, and the kind of latency you're going to add to each transaction is really unacceptable. So let's get to the meat of how the decryption is done today. Today, we use long-term private keys known as RSA static keys. So let's talk about what that is. Up till now, basically, we've used certain public key, private key algorithms that work in this manner. The basic concept is that you keep the private key to yourself. You keep it hidden. No one should know that. And to generate the public key from the private key, it should be quite simple. But to go the other way, it should be very, very difficult. In fact, nearly impossible to do that. So then you give everyone the public key and keep the private key hidden. And because no one can deduce the private key from the public key, you're safe in doing that. And today, one of the key algorithms often used is called the RSA algorithm, invented quite a long while ago by 1978 by Ron Rivest, Adi Shamir, and Leonard Edelman. And what this relies on is hard to invert functions. Because, you know, the first time I heard about this, I couldn't let it go. I'm like, okay, how does this even work? And my mom happens to be a mathematician. And so I worked with her and she laid out for me some of the things of exactly how hard to invert functions work, why prime number factorization is a problem. And in fact, let me go through that with you real quickly. A prime number has only two divisors, of course, 1 and itself. The following are the smallest 25 prime numbers, 2, 3, 5, etc. When you do prime number factorization, you give a list of all the prime number factors. So let's say that we have the number 15. The two prime number factors of 15 are 3 and 5, of course. If you have 8, you have 2 times 2 times 2. So that's the list. You have 2, but it's 3 times. The reason why prime number factorization has been used in RSA, or in fact is used in RSA, is because it is called a hard to invert function. What that means is that there's no algorithm, there's no formula for prime number factorization. The only way to do it is via brute force. So it's very easy to calculate it one way. 15 is, of course, a very small, a trivial example, but you can take two extremely large prime numbers and very quickly come up with another extremely large number. And if you just have that large number, to go backwards is extremely difficult. So here's the example of RSA, and I'm not going to go through this formula in detail, but you can see the things they're doing is they're taking prime numbers, again, because prime number factorization can't be inverted. Modulus, another hard to invert function. Modulus, of course, is the remainder function. And then exponentiation. Again, a number of hard to invert functions are done. Now, there is one thing that people are working on, which you may be hearing about, which is quantum computing. One of the areas that they're working on in quantum computing is this particular problem, the problem of prime number factorization. And that is, if we had more time, we would talk about the state that is in. But you'll see that the mathematicians are working on this particular problem. So, but what really happened in reality is that private keys were stolen. You'll recall in RSA, RSA depends on the private key being kept secret. And so what happened is, rather than deduce the formula, a number of people in many areas actually stole the private keys. And this came out because of the Snowden revelations, that a number of spy agencies had done some somewhat unethical things and stolen private keys from many areas. So then we come about to something called forward secrecy. This used to be called perfect forward secrecy, but there's no such thing as perfect. So at the IETF, if you say perfect forward secrecy, people will correct you and say, no, it's just forward secrecy. So forward secrecy now depends on using the DiffieHellman algorithms. And so I'll go into what that is. The DiffieHellman algorithms do not have this concept of a key that's passed over the wire. Let me go into how that is. And you'll see that in a lot of the drafts that are best usage of TLS and so forth are now calling for forward secrecy. So, and of course, forward secrecy is recommended in a number of other things, Quick, TCP Inc., etc., Deprive. And now, As I say, let me be clear. I'm not saying that privacy and increased security and encryption are wrong. I'm just saying that there has to be a balance, because really, are you increasing security when you're keeping the bank from being able to see if there's malware? I would say that maybe you're decreasing security. It's a far more complex and nuanced problem than we have been talking about. It's really not a balance between privacy and security. It's a multivariate problem. It's not a binary problem. And that's one of the things that we have been trying to talk about at TLS. And I think we're making quite a bit of headway. So what the problem is now, for which we're seeking a solution, is how are you going to capture packets in the middle of the path, and how are you going to do diagnostics, and so on, and how to do decryption. The draft that we're working on will be talking about a proposed solution to this. We're still right in the middle of working within the group to really work out the solution amongst ourselves. And I will certainly post to our list for comments when we have it. Right now, we're all working with each other to see exactly what to do, because quite a few things, as far as enterprises are concerned, are likely to break. Our WAN optimization, billing, security monitoring, and so on. And as I say, we can't really do it with SSL proxies and SSL interception. There are people who are working on potentially a Middlebox protocol. It's likely probably sometime next year you'll see something like that. We're talking to some people. That's really not our concern at this point, but as I say, I know people who are working on a multi-point type of protocol. So let's talk about DiffieHellman. How does DiffieHellman ephemeral work? Well, the key is never passed over the wire, and both ends actually calculated, and it's ephemeral or short-lived. So the Wikipedia formula is actually quite good. So let's just go through it. Let's say what we decide to do is we decide to pick a particular modulus, a remainder, and a particular base. Let's not get into what primitive root modulo is. Again, when I got into that, I asked my mom. I said, Mom, what is primitive root modulo? and so, but let's not. She explained, but let's not get into it. But let's just go through the formula. So let's say our favorites, Bob and Alice. Alice chooses a secret integer. Let's say 6. Now this, if you look at some of the drafts at IETF, they're going to call that secret integer the private key, okay? And then you send, I'm simplifying a bit, but that's essentially what they're doing, because you won't see secret integer and GA to the mod P. You'll see private key and public key. So it can be a little confusing, but let's go through the formula first. Okay, so you pick a secret integer, let's say 6, and then what you do is you send Bob the result of you take G to the A, to the exponent mod P, where P is 23. So basically what you've done is you've done A is a 5 to the power of 6 mod 23. Or 8. So you send Bob 8. That's over the wire. And so anybody can see it. Bob, he does the same thing. He chooses the number 15. And then what he does is he sends Alice B, which is a GB to the mod P, or 5 to the 15th power mod 23, which is equal to 19. You notice that the base, which is G, that has to be agreed upon. So both parties have to agree on the base, and that's done offline, if you will. You have to agree on that, and then you pick the base and the modulus have to be agreed on, and then the secret integer is pick, and then when you get the other person's A or B, then you just reverse it, and so then you do 19 to the power of 6 mod 23, and you get a shared secret, which is 2. Bob does the same thing. He does 8 to the power of 15 mod 23. He also comes up with 2. So that's the key, is that because reversing this formula ends up giving you the same number, there's no need to pass anything over the wire. And so this is how DiffieHellman works, is that there's no more keys that are sent over the wire. It's just the G to the A mod P. That is the only thing that is sent over the wire. So here's another thing, again, from Wikipedia. And this is, again, it's a different way of looking at it, is by mixing colors. The bottom line is that in the end, you both come up with the color brown. And that's what's the interesting thing is, because what do you do with that color brown is that's what you use to encrypt everything. And so then that is how DiffieHellman works. So we've also got to change the handshake. Even in TLS 1.2 and below, you can use DiffieHellman. So this is a simplification of what the regular handshake, SSL handshake, looks like using RSA. But you'll see now that with DiffieHellman, you've got the server key exchange. Now, of course, TLS 1.3, everything is very, very different. In fact, here's a client hello in Wireshark of a TLS 1.3. And you'll see that in the many things are changed. I'll be doing a whole thing of exactly what the handshake looks like, what's in the new extensions such as key share, and a new extension that we hope to propose called TLS visibility. As I say, we're writing the draft for now for our needs. So thank you so much. And let me stop sharing. And if there's any questions, I'm happy to answer. Yes, can you guys still hear me? Yes, hello? Okay, Vinayak and Dhruv, if we want to finish up, do you want to say some final thoughts here? Thank you all so much.
Thanks, Nalini. This is Anand.
Yes, hi.
Yeah. So I think there is no question. And Dhruv, are you there?
Yeah, I'm not hearing Dhruv either. Uh-huh.
I think we can finish up.
Sure, sure. Yeah, maybe Dhruv is having trouble connecting.
Sure. So we are so with this we will be doing our next webinar next month, and when we are working with our DNSSEC technical session in the next webinar.
Great. So, yep. Let me encourage everybody to come to the connections and sign up. And I hope to be seeing all of you very soon in Bangalore.
Thank you.
Okay, thanks so much. Okay, we'll talk next time.
Yeah, thank you everyone for joining the webinar.
Yeah, thank
Okay,
you.
bye.
Bye-bye.
হ্যাঁ হ্যাঁ বলছিলাম যে কালকে যে আপনারা সকালে যাবেন ওখানে সিট হবে একটা আমিও যেতাম তাহলে হ্যাঁ হয়ে যাবে ঠিক আছে কালকে তাহলে আমি যাবো গাড়িটা কত দিতে হবে সে কালকে গাড়িতে উঠলে নেবো ঠিক আছে এই 30-35 টাকা লাগবে 30-40 টাকা লাগবে আর কি ঠিক আছে